Okay, hello pre-calculus students. This video is going to be essentially the last video. Not essentially, this is the last video you're going to see for the semester. Next week is going to be for catch up on stuff that maybe you've fallen behind on. And I'm going to have some extra credit stuff, a couple small extra credit things, not worth too much, maybe 5 points or stuff. But then this week essentially is going to be your last test. I wouldn't think of it as a final, just kind of last test. It's going to be worth the same pretty much as all the other tests. It's just going to be your last one. It's going to include this lesson on limits and just a few questions from the past. Okay, but which I will go over, so it's not a big deal. Okay, so limit. Here's what a limit is talking about basically. If we have a graph of function, okay, let's take this function. F of x is equal to 3x plus 1. And I'm going to do a really fast version of this, but still, even with the fast version, this entire video is going to be probably 20 plus minutes, okay? So a really fast version, 3x plus 1. I'm going to graph 3x plus 1. That's going to look something like this. Okay. That's the line 3x plus 1, and it looks something like that, okay? So what a limit asks you is, and a limit looks something like that. Here's the notation for a limit. The limit, for example, I say as x approaches, okay, that's how you say it, as x approaches 1, I just chose 1. I could have chose 5, -7, whatever I want, 0. I just happened to choose 1. Okay, choose 1. The limit as x approaches 1 of 3x plus 1, well, I want to know what is that limit. First of all, does that limit exist? And if so, what is it? Okay, well, simple, as x approaches 1. X is 1 right here. As x approaches 1, I'm just going to look up, and it obviously reaches 4. Simple as that. That's our limit. It's visually obvious. Now, how do I know it's visually obvious? Because from the left of 1 and from the right of 1, it's approaching that same number. Seems obvious, right? That's why I'm starting off with an easy question. It seems very obvious. What's another way of doing it? I don't even have to have a graph. Another way is just plugging it in. I could just plug in to 3x plus 1. I'm just going to plug in 1. Boom, same answer, got 4, right? Okay, so that's the limit. So you may be saying, oh, well, what's the difference? You're just plugging it in. True. And really there isn't, because the value of f of 1, meaning the value of f of 1, that means when x is equal to 1, is equal to 4. So clearly the limit is 4 in this case, okay? Because it's a straight line, it's continuous. However, that won't always be the case. And you're thinking, well, no, it has to be the case. Not necessarily. Okay? And you'll see an example where that's not necessarily the case. You'll see a graph, I should say, where that's not necessarily the case. All right, so I just want to break this down a little bit. Okay, so yes, the limit as x approaches 1 of 3x plus 1 is 4. Now, I just want to break down a little bit more. What does that mean? Well, there's two ways to break down this limit as well. Okay, you can also do a directional limit. Okay, it's not the same as the limit. If I say the limit as x approaches 1, that exists. Yes, the answer is 4. But what does that mean? That means this also exists. The limit as x approaches 1, and I'm going to put a little positive sign. That means from the right side. Positive meaning from the right. Of 3x plus 1. Well, what's that going to be? Well, this one's also going to seem very obvious too. Okay, as x approaches 1 from the right side, okay, from the right, so the right of 1. From the right of 1, it's going down this way. It's going down this way, and it's clearly approaching, boom, 4. That's just obvious. Let's try this then. The limit as x approaches 1, not from the right side, but from the left side. So I'm going to put a little negative right there. Of, what is it? 3x plus 1. Okay, what is that equal to? Well, that's simple. We're looking at 1, so everything less than 1. Approaching from this side, everything less than 1. And that's obviously, again, reaching 4. In order for the limit of x of 3x plus 1 as x approaches 1, in order for this to exist, this and this from the right and from the left, they should be approaching the same number, 4 and 4. Okay, now, well, yeah, isn't that always the case? It's not always the case. And let me show you an example of a graph where that is not always. something look like this. Okay. This graph, okay? This function is a function, yes, passes vertical line test. Okay. Now, if I were to ask you guys on this one, what's the limit as x approaches 1? Here's the tricky thing of this function. Okay. The limit of f of x as x approaches 1. Okay. We'll call this will be f of x. Okay. This entire graph is f of x. So what's the limit of f of x as x approaches 1? Now here's the interesting thing. As x approaches 1, let me make this a little more clear. As x approaches 1, here, you may be saying, oh, that's simple. As x approaches 1, that's a 1. Oh, wait a minute. But up here, it's a 4. So which one is it? Is it a 1 or is it a 4? It seems kind of confusing, okay? Well, there's two different questions here. What is the f of 1? That's a completely different question. That's saying what happens when I plug in 1. Well, if you plug in 1 here, if you look at 1, it's clearly not 1 because there's an open holder. That means when you plug in 1 for x, you're not going to get 1 for y. That is not going to happen because 1 does not exist over here. This is an open hole. When you plug in 1 for x, what you do get is a 4 because that's what f of 1 is. So what is f of 1? Simple. F of 1 is equal to 4 in this case. In this, our original problem, when you plugged in 1, yeah, you got 4. Cool. But in this case, you get a 4 if you plug in 1. Just look at the graph. For 1, you get a 4. But here's the question. The fact that f of 1 equals 4 is irrelevant to me. Because remember what I said, from the left and from the right, you have to get the same value. So you have to get the same limit. So let's find this out. The limit as x approaches 1 from the positive side. Let's see what that is. From the positive side. So from the right of 1, it's coming and getting to 4. Okay. But the limit as x approaches 1 from the negative side, okay? So again, the limit's just saying what it's approaching. It doesn't say it's going to hit this for sure. It's just saying we're approximating, what's it approaching. So from the left-hand side, right here, look at my finger, as it's approaching, it seems to be approaching 1 right here. I didn't graph it too well, but I meant to graph it at 1. So as x approaches 1 from the negative side, it's coming closer and closer and infinitely closer to 1. I know it doesn't actually reach 1, but it's getting close to 1. Now look at these two. The limit as x approaches 1 from the positive is 4, but from the negative is 1. It's not reaching the same thing. It is not reaching the same limit. So what does that mean? That means the limit as x approaches 1 for f of x, that does not exist because it's two different numbers. Okay, so I can't say, oh, well, this or this, because one of them is the answer. No, it's not. Neither of them are the answer. It does not have a limit as x approaches 1. Now, so this would be does not exist. The limit as x approaches 1 of f of x just doesn't exist. Okay? However, be careful. If I ask you specifically the limit as x approaches 1 from the negative side, if the question just asks for that, for that one, yes, it is 1. Because coming from the left, it gets close to 1. Coming from the right, it gets infinitely close to 4. Okay, so the directional limits do exist, but the overall limit of as x approaches 1 does not exist. So just be careful of what the question's asking. Okay, so now let's go a little bit more. Let's go a little bit more hardcore. Let me give you an example of an actual function where the limit would not exist. Okay, and again, this is going to be pretty easy. It's not going to be too hardcore for you guys. It's basic algebra, really, but just more the idea that's important. What if I said this? The limit as x approaches negative 3 of x plus 2 over x plus 3. Okay? If you were to graph something like this, actually, you know what? I shall. Okay? Okay. And then one second. Let me get the exact graph up real quick. Just hold tight. What is it? X plus 2, x plus 3. Let me get that exact graph up. Plus 2 over x plus 3. Okay, we have simple asymptote at that asymptote. Okay. Okay, that's at 1. Okay, sorry, just real quick. All right, we're gonna have a graph that looks something like this. X plus 2 over x plus 3. We have our two asymptotes. We're gonna have a graph that looks something like this. Okay. Let me just clear this out. Okay. So this is the graph of x plus 2 over x plus 3. And I'm asking for the limit as x approaches negative 3. Now, first and foremost, this seems very obvious. If I plug in negative 3, simple, you're going to see that you're going to get negative 3 plus 2 over negative 3 plus 3, which is going to yield negative 1 over 0. Boom, that automatically tells you the limit does not exist. That is obvious, and by looking at the graph, it's also obvious. Negative. Watch this. Coming from the left-hand side from negative 3, coming from the left-hand side, negative 3. I want you guys to think about it. Here's negative 3. As we're approaching the left, you see where it's going? It's going up and 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 up. You might be tempted to call that infinity, and you wouldn't be wrong, but technically the word for it is unbound. Okay, because it's going, it doesn't have any limit. It doesn't have a bound. It does not, like out of bounds. It doesn't have one. It's unbounded. Okay, from the right hand side approaching negative 3. From the right hand side, and it's free falling down as it's approaching negative 3. That is also unbound. But the important thing is this approaching from the left-hand side is going in one extreme direction. Approaching from the right-hand side is going in another extreme direction. They're obviously not approaching the same number, whatever the infinity, negative infinity, whatever you call it. They're not approaching the same limit. So if they're not approaching the same limit, that tells me that this limit does not exist. Algebraically, we also figured it out. It's over 0. It does not exist. Now, here's the question. What to use a table? Can I prove that with the table that this does not exist also? Because the limit as x approaches negative 3 from the positive side and the limit as x approaches 3 from the negative side, these are not equal. They're not the same thing. One's going really up that way, one's going really down that way. All right, let's use a table to prove this real quick. Okay, so here's what I'm going to do. I'm going to pick numbers to the left of negative 3. That means less than negative 3. But I'm not going to waste your time and do negative 4 and negative 5. I'm going to get as close to negative 3 as possible. Okay? I'm going to get as close to negative 3 as possible, but put less than negative 3. So what number is less than negative 3? Well, I can be cute and say, oh, less than negative 3, that's negative 4. That's not close enough. I want even closer. Okay, how about negative 3.1? That's cute. I want to be even closer to negative 3. Okay, let's do it for sure now. Negative 3.0001. Yeah, obviously we can get even closer, but let's just try that, okay? So I'm going to plug that in and see what I get. Negative 3.0001 plus 2 is going to get me negative 1.001 over, and then negative 3.0001 plus 3 is going to get me 0.001. negative. So let's see what that's going to get us. Just get my calculator out. Okay, that is going to be negative 1.001 divided by negative 0.001. That's going to get us 1,001. 1,001. A big number. Now, okay, that's from the left. Now from the right. What's to the right of negative 3? Okay. Now you can say, oh, to the right of negative 3 is negative 2. You're right. That's greater than negative 3, but you're not thinking close enough. Oh, to the right of negative 3 would be negative 2.9. That's cute. I want you to get really close. Okay, how about negative 2.9999? Okay, now we're talking. Let's plug in negative 2.9999. Let's see what that gets. Negative 2.9999. And then over here, negative 2.999. Okay, that's going to get us negative 0.9999 over, that's going to be plus 0.0001. Okay, let's see what that gets us. Negative 0.9999, 0.00. That's going to get us negative 9,999. Clearly, this is going crazy to the positive. This is going crazy to the negative. It's not even close. They are not going to be anywhere. They're not approaching the same limit. This limit does not exist. Okay, seems obvious here. Okay, so now let's move on to some other limits that possibly do exist. Okay, and let's test out, see if we can figure it out. Now these ones are going to be a little more confusing. Okay, and I'll show you why. Let's try this one. The limit as x approaches 3. As x approaches 2, I'm going to do as x approaches 2 of 3x squared minus 5x minus 2 all over x minus 2. Okay. We're not going to graph this right now. If we were to graph this, it actually would look like a line. You may have already figured it out why it looks like a line. Maybe you haven't. But here's the question. I'm going to just plug it in. What's going to happen if I just plug it in? If I plug in x as 2, I'm going to stop. I don't give a damn what happens up there, because on the bottom, I'm going to get a 0. I'm going to get a 0. Now, you might be tempted to say, oh, well, anything over 0 is done. That's it. Limit does not exist. Does not exist. Boom, done. But you would be wrong actually in this case, because here's what's going to happen. In this case, if you were to plug the 2 in, you would actually get, I'm going to fast forward it for you, okay? That over that, you'd actually get 0 over 0. The previous problem we had done, remember we had gotten like, what was it, like 1 over 0 or something else over, or negative something over 0? I forgot what it was, okay? But we didn't have 0 over 0. When you have a number over 0, non-zero number, like negative 5 over 0, 3 over 0, whatever over 0, that is, the limit does not exist. But if you have 0 over 0, that is called indiscriminate. I'm not going to spell it out. Sorry, not indiscriminate. Indeterminate form. Indeterminate form, okay? But basically what that is that it's telling you that, hey, a limit actually does exist, but you got to delve a little deeper, okay? Because if we were to graph this, it would now, and I agree, this is not a fun one to graph, but if we were to graph it, it would look something like this. Let me just get that out for you. That would look something like this. But it would have one major caveat. And you may be saying, oh, well, that's just a straight line. Yeah, but it has one major caveat. Okay, so take a look at that line. Something interesting about that line. Okay, that line just looks like the line of 3x plus 1. And you know what? It is the line of 3x plus 1. However, x cannot equal 2. How come x cannot equal to 2? Well, simple. If you plug in 2 right here, you get 0 on the denominator. Cannot have that. That's why at 2, this has a hole. Okay? So it cannot equal. So you may be saying, yeah, okay, so it doesn't exist. It's over. No, but remember what I said. Limit as x approaches that 2. From the left, it's approaching 2. From the right, it's also approaching 2. If those two are the same directionally, then this limit does exist. And it absolutely does exist. The limit as x approaches 2 is going to be, whatever the hell this number is. The problem is I can't plug this in because every time I'm plugging it in, I get 0 over 0. So what am I going to do? I'm going to use this graph. I can't even understand. I can't even read my own graph. I have no idea what number this is. 2, I don't know. That looks like 7, 8, I don't know. So here's what we're going to do. We're going to do it algebraically. Some of you may have noticed that this can be factored. It can be factored. 3 times negative 2 is negative 6. That's negative 5. I am going to do an x method on this, okay? Again, algebra 1 and algebra 2. What multiplies to negative 6 adds up to 5? Okay, let's see. 3 times 2. That would not work. It would have to be 5 and 1. 6 and 1. The negative would have to be 6. Okay, but don't forget, we're doing the x method factoring, diamond method. You have to divide by that a. Okay, this simplifies to negative 2, and that's 1 over 3. So what does that mean? That means x minus 2 is one of the factors, and 3x plus 1 is another factor, all over x minus 2. So let's see what can happen now. We can now cancel the x minus 2's. So what did we just left with? 3x plus 1. So what does that mean we can do if I want to find the limit as x approaches 2? Simple. Just plug in the 2 and what remains? The 3x plus 1, right? So when we plug in the 2, we get 6 plus 7, which is 8. So what is the limit as x approaches 2 of this whole thing? It is equal to... That's our answer. Okay? That's our answer. Now we figured this out because graphically, if you look at it, you go like, oh, it has a hole. Yeah, but graphically, it's still approaching the same number, which is right here, and that would be 8 right there. Still approaching the same thing. All right, so let's take it up a notch. Now, what else can I have? I can do something like that. I can do something like this. Another one that involves... What if it has something like this? The limit as x approaches, what did I have? 0 of x plus 8x squared over x squared. All right, simple. Let's do this fast. I'm not even going to graph it. X approaches 0, put in a 0 there. I'm going to have a 0 on the bottom. However, on top of that, plugging in 0, that's going to get me 0 plus 0, which is 0. Indeterminate form. What does that tell me? That tells me a limit might just exist. Might just exist. If you notice, they have a common factor here, which is x squared. If I pull out an x squared from here, that's going to give me x plus 8. And on the bottom here, I got x squared. Cancel them out. I'm left with x plus 8. Now I can use algebra to find my limit. Plug in the 0. 0 plus 8 is 8. We got our limit. Our limit exists. It is 8. Okay. Now, this can get more complex. You will get a question that's a little more complex, has some fractions in it and stuff like that, and that's okay. Just letting you know. One thing you are going to see here, I am going to give you a hint. Make sure you have law of cosines available. You're going to see a law of cosines problem on your test, okay, that you're going to need to use. Another thing you're going to want available as well is unit circle. You're going to have a question that you're going to need the unit circle, okay. One last thing I want to show you guys. So unit circle. So you're going to be doing a solving problem, solving a trig problem using the unit circle. You're going to be doing a law of cosines problem also on your test. Now you are going to have this one more question, which is called derivative. Now, here's the interesting about a derivative. Okay, it's going to say find the derivative of something like this. Let's say something as simple as that. Find the derivative of f of x equals x squared. Well, it's pretty simple. Do you guys remember the difference quotient that we did? Okay, and if you remember the difference quotient, it was f of x plus h, okay, minus all over h. Now, if you remember the difference quotient, now I'm not going to get into like, how the derivative works. We just don't have time for that on a video like this. It's too long, okay? But here's the step. Find the difference quotient of that. So in this case of x squared, that is going to be, let's see, that is going to be x plus h squared minus x squared all over h. Okay? So x plus h squared. Okay, so that's going to give us that's gonna yield. So I'm gonna erase this difference quotient just so we can. I just plugged that into the difference quotient. Okay, if you remember what we did with difference quotient. So that's gonna get us x squared plus 2xh plus h squared minus x squared all over h. We're gonna cancel out x squared and negative x squared. H is going to cancel out one of the h's and this h right here. We're going to be left with 2x plus h. That is step one. Step two to finding the derivative is you find the limit of that difference quotient as h approaches. Simple as that. The limit as h approaches 0. And then you can already do that in your head. You plug in 0 over here. You got 2x. So the derivative of this is equal to 2x. You want to know a little shortcut? It works for most cases here. Take that exponent and move it as its coefficient, and you got 2x. That took a lot faster than doing this whole thing, okay? But that's the proper way of doing it. Anyways, that's it for now. Oh, let me the homework questions. Homework questions. Flip it between the 30 minutes here. Sorry guys, but I wanted to do this rather than doing multiple videos. It just takes longer for me to upload it too, and all right, so right here are your questions. Remember, any of these answers right here, the answer could be the limit does not exist. I'm going to give you a hint and tell you that only one of them, the limit does not exist. Every other one is going to have a limit. Okay, but just please be careful. For number 5, it's asking you to use a table. I want to actually see you use a table for that limit, to find that limit. It should be pretty straightforward. Good luck, guys, and practice test tomorrow, which is Wednesday, the 3rd, right? Today's the 2nd. I lost my track of time. And then on the 4th, which is Thursday, we'll have our tutoring session, our Zoom tutoring session. Friday, you'll have a little test on this. And for all intents and purposes, that's pretty much it. I have to start putting senior grades in on that Friday. I have to finish senior grades in on that Friday. And the following week, next week, will just be catch up on anything you have and some extra credit stuff, okay? And then I'll finalize your grades before I put it in. All right, thanks, guys.